Hi, Pre-Calc students. This is the beginning of Chapter 5, well, Part 1 of Chapter 5. So it is 5.4 and 5.5 in your book. We're talking about right triangles, and we are finding side lengths and angle measures using trigonometry, or maybe you've heard it just kind of called SOHCAHTOA in the past. If that rings a bell, you've perhaps learned this stuff before. So just kind of an overview of trigonometry ratios or trigonometric ratios. They only work with right triangles, so you have to have a right triangle in front of you when you're doing it. Each of the sides that touch the right angle, so this side and this side, they both touch the right angle. Those are called legs, and then the side across from the right angle is called the hypotenuse. So every time you're working with a right triangle across from the right angle, you'll find the hypotenuse. A couple things with that. The hypotenuse is always going to end up being your longest side. So when you go back and check your work, always make sure that it's working out where the hypotenuse is the longest side. Okay. And then as you're working through your trig ratios, this angle right here, this like circle with a line through it, that's called theta. So if you hear me say that, it's just a Greek letter. It's just like a variable. It's no different than using an x or a y. It's just a lot of times that's the variable that's used for angles. Across the triangle from that theta, or the angle that you have, or the angle you're using, is called the opposite leg. And then that leg that's right next to your angle is called your adjacent leg. So you're always working with opposite, adjacent, and hypotenuse when you're working with these trig ratios, okay? Sine, the sine of an angle, if you are abbreviating in your work, you usually use SIN. Sine of theta is the opposite side divided by the hypotenuse. Cosine, abbreviated COS, is adjacent over hypotenuse. And then tangent, or TAN, is opposite divided by adjacent. And you may have seen this stuff sorted out this way. SOHCAHTOA. That's just a way to remember it. So sine is opposite over hypotenuse, cosine is A over H, and tangent is O over A. All right, oops. Oh my. Okay, so first example. If angle J is 50 degrees and side J, little j, is 12, find R. So first thing you want to do is draw your diagram and fill in your known information. So angle J is 50 degrees. I'm going to fill that in. And then little j is 12. And we need to find R. Okay? So what I always do is I just ignore the side, the leg, or the hypotenuse that we don't care about. And in this case, we don't care about the G. We don't have G. We're not asked to find G. It really doesn't matter. So we're just going to ignore that. And then label the other two sides. So R is across from the right angle, so it's the hypotenuse. And then the J, the 12, that's across from the angle that we were given. So that's going to be our opposite side. Okay, now the question is, which trig ratio has opposite and hypotenuse? So opposite and hypotenuse, that's your sine ratio. So we're going to set it up. Sine of 50 degrees is equal to 12 over R. Okay, now it's just an algebra problem. Sine of 50 is just a number. 12 is obviously a number, R is a variable. So it's just an equation with one variable. So we need to get R by itself. To do that, what I always tell students is when you're just getting used to these and you're not taking any shortcuts, multiply by the denominator. If we don't like fractions and we want to get rid of fractions, multiply both sides by R. That will get rid of your fraction. Now you're left with R times sine of 50 is equal to 12. Okay, and we're just solving an equation. We need to get R by itself. So we need to get rid of times sine of 50. Opposite of times sine of 50 is divide by sine of 50. Whatever you do to one side, you got to make sure you do it to the other side. Then that's gone, and you're left with R equals 12 divided by sine of 50. And then it's just a matter of typing that into a calculator. And it doesn't matter what calculator you use. I'm going to show you how to do it on both your graphing calculator and Desmos. So I'll do this one just on the graphing calculator. So if you have a TI in front of you or you're using the one on the Chromebook, either way is fine. What you need to make sure you do if you're using the TI though is make sure you're in degrees, not radians. So our angle was given to us as 50 degrees. We need to make sure the calculator is in degrees. Otherwise, we're going to get every single problem wrong. So to do that, you're going to hit the mode button. And then you're going to scroll down, I think, just twice. It's the third one there. See how radian is clicking right now? Or beeping? Blinking? Scroll over to degree and hit enter. Oops, I missed. So mode, over to degree. Did it again. There we go. And then you can just hit second quit. Now it's in degrees. Okay? And then we're just typing in, what was it? 12 divided by sine of 50. Sine button is right there. You don't need to click degrees or anything, just 50. And it's going to give you 15.66. We're going to round to the nearest tenth, so just one decimal. So 15.7. And we're done. All right, next example we have, if angle G is 22 degrees and little g is 12, find J. So fill in your known information. So find angle G, that one's going to be 22 degrees. Little g, they're telling us, is 12, and we want to find J. Okay, so in this case, we don't care about R. They're not giving us R, they're not asking us to find R, so ignore that one. Label your other two. So it looks like across from 22, so that's our opposite, is 12. And then the J is right next to the 22. It's not the hypotenuse, it's a leg. It's helping make up this right angle. So it is the adjacent. So now we just have to remember which trig ratio is opposite and adjacent. That's tangent. So tan of 22 is equal to 12 over J. Okay, now you guys are in pre-calc, so I trust that you don't need to go through every single step every time that I did in the last problem. You're going to start to figure out that when your variable is in the denominator, like it is now, you're going to technically multiply both sides by J and then divide both sides by tangent of 22. If you want to just skip right, kind of do those in your head, but when you're writing it down, just kind of skip to that final step. I'm definitely going to be okay with that. So you're actually going to end up with J equals 12 divided by tangent of 22. So I'm just going to flip back to our last slide, and you can see what I'm doing here is I'm kind of just like skipping this step here and going on to the last step. All right, now I'm going to do this one on Desmos just so you can see how to do it on there. Same idea. We have to make sure that we have it in the right mode. To do that, I got to extend my screen a little bit more so you can see. Just hold on right there. Okay, you need to find this little wrench right there. And then there's radians and degrees down here. So you need to make sure that you're in degrees. I think it defaults to radians, so you're going to want to make sure that you flip that to degrees. And then all you have to do is go in here and just type in, what was it, 12 divided by tangent is going to be in the functions. Just find tangent of 22. And your answer is going to pop up as 29.7. All right, one more example here. Angle A is 32 degrees in this case. And little b is 13. Little b is across from big B. So if you're not given the sides, they just correspond to the angle. So across from big B, you're going to find little b. They're telling us that that is 13. And then they want us to find little c. So they want us to find this side over here. So looks like we are given the hypotenuse and we're asked to find the adjacent side, the side right next to 32. Adjacent and hypotenuse, that's our cosine. So our setup is going to be cosine of 32 is equal to adjacent, which is C, over hypotenuse, which is 13. And this is an easy one. If your variable is on top, all you have to do is multiply both sides by the denominator, and you're done. See how your C is already by itself? So you just need to type this piece into your calc, and you're done. So 13 times cosine of 32. 13 cosine 32. And we get 11.02, so just 11.0 is fine. Alright, I'm gonna actually skip that one and go to this one. Alright, so this time we're given two sides and asked to find an angle. These ones are actually a little bit easier than the regular trig stuff because you don't have to do much algebra. You just kind of set it up and type something into your calculator. So first of all, let's look at our triangle and fill in what we know. They're giving us little a, so across from big A is little a. And then across from big B is little b. And they want us to find this angle here. They want us to find angle A. Okay, so according to that angle A, that angle that we're trying to find, we have the opposite side and we have the hypotenuse. So opposite and hypotenuse, that's sine. So we're going to set it up just like normal. So sine of A is equal to opposite, which is 4, over hypotenuse, which is 7. Okay, now we need to get that A out of the sine. So to get that A out of there, don't divide. Absolutely don't divide. There is no multiplication sign between the sine and the A. That's sometimes people get confused by that and they try to like divide both sides by sine and that doesn't work. What you need to do is take the inverse sine of both sides. Inverse sine, sine inverse. Okay, that will get your A by itself. Okay, then all you need to do is type this into your calculator. So I'm going to jump back to the TI for this one. And you're going to hit second sine. And then you're just going to type that fraction in. So it was 4 over 7. 4 divided by 7. Hit enter. And there's your answer again, round to the nearest tenth. So 34.8 degrees. And then we'll do one more of those. So if little b equals 3 and little c equals 5, find angle B. Okay, before you start going crazy with this one, take a look at it. It kind of doesn't make sense. Not kind of. It doesn't make sense. So they're telling us right now that this side right here, which is the hypotenuse, they're telling us that that side is 3, and then they're telling us that this leg here is 5. That is not possible. It is not possible that the hypotenuse is actually shorter than a leg. Also, if they're asking us to find angle B, there wouldn't really be much to do. We would just say that it's 90 degrees, but like I said, that's not going to work. It's not possible to have a triangle that looks like that, where the hypotenuse is shorter than a leg. So for one like that, and I don't know if that's actually going to come up, but it's not bad that that came up in the notes. That one is not going to be possible. The way that triangle is drawn, okay? We could maybe draw a new triangle where B is not the 90-degree angle. Maybe we could flip-flop C and B and make it work, but we're not going to. We're just going to not do that one. Okay. Next example, we're going to solve the triangle. Solving the triangle means finding all of the missing sides and all of the missing angles. So just using what we've been using, but kind of taking it a step further and just finding everything instead of one missing piece. So I'm just going to start by filling in what we know. So 21, little c is over here. That one is 30. And then we're going to be looking for little b. And then we're going to be looking for some angles. So kind of you got to figure out what you need to find first. We could find that little b first using the Pythagorean theorem. We could do, well, I guess in this case it'd be a squared plus c squared equals b squared. So leg squared plus leg squared equals hypotenuse squared. We could do it that way. Or we can get around that and we can just look for one of our angles first. So maybe we'd find angle C first. So according to angle C, we are given the opposite side and the adjacent side, which would be tangent. So we could do tangent of C is equal to 30 over 21. And then remember, to undo a tangent, we would take the inverse tangent of both sides. So we would type in our calculator inverse tangent 30 divided by 21. You can do that on Desmos too if you want. Inverse tangent 30 divided by 21. Oh, shoot. And we're going to get 55 degrees. So we can fill that in. Okay, then we don't have to use trig to find angle A because all three sides of a triangle need to add up to 180 degrees. So we already have a 90-degree angle and we already have a 55-degree angle. So I think what's left is 35 degrees. So angle A is 35 degrees. We can just kind of add that to our list. And then the last one we need to find now is this little b. So that little b, we can maybe use our 55-degree angle. B is the hypotenuse, and we can use, doesn't matter, either little a or little c. Let's use little a. We can call that adjacent, so we'd be using cosine. So cosine of 55 is equal to 21 over b. And then I'm going to use our shortcut, and I'm just going to say, okay, I'm putting b on the other side, and then I'm going to end up dividing both sides by cosine of 55. Find the calculator, and we're doing 21 divided by cosine of 55. 21 divided by cosine of 55, and that's going to give us 36.6. So little b is 36.6. And then you kind of just want to double check, make sure that that actually makes sense. 36.6 should be the longest side because it's the hypotenuse, and it looks like it is. You have 30 and 21 for legs. So we're good. So it looks like we have all three angles solved, all three sides solved. Okay. Now we're going to jump into some application problems. So we are using the same stuff, using trigonometry still, but this time we're going to have some word problems. We're going to have to set up some of the triangles and solve from there. So just a couple little vocabulary words or little situations that come up. One of them is angle of elevation. Angle of elevation is pretty simple. It is what you think it is. It's how I think about it is the angle that you would lift your eyes to look at something above. So you have this little guy here. If he was looking straight ahead, that'd be a horizontal line. And then if he kind of lifts his eyes to look at the top of the tree, the difference there is the angle of elevation. I think pretty simple. Angle of elevation is usually on the ground, or usually from, eye level up. It's at the bottom of your triangle. Angle of depression is a little bit more confusing. Angle of depression is the angle that you would lower your eyes to look at something below. So if you kind of picture a guy on top of a building, if he was looking out horizontally and then he kind of looked down to look at a car or something, that angle there is the angle of depression. Okay. Now, the tricky thing with angles of depression is a lot of times when you draw your triangle, your angle of depression is actually not in your triangle. So a lot of times, you might be asked, if we just use this situation here, we might be given some information, we might be given the angle of depression, and then we might be asked to find like the height of the building. Well, you might draw your triangle, here's the height of your building, maybe they gave you like a horizontal distance, so maybe they said like the height is 12, I don't know, 12 what, but, and then this distance is maybe 10, and then they gave you the angle of depression. Well, that's not actually a part of your triangle, it's kind of on the outside of your triangle. So the trick, or what I always do, is I always realize that the angle of elevation is equal to the angle of depression. They're the same. So if they give you the angle of depression, if they say, all right, this angle out here is, I don't know, 24 degrees, okay? And that ends up being outside your triangle, the trick is that you can actually take that 24 degrees and put it at the bottom of your triangle, where the angle of elevation would be. The reason for that, if you think back to your geometry class, this horizontal line and this horizontal line are parallel, and then you have these little corners here. You remember from geometry, those are called alternate interior angles. Alternate sides of this diagonal line, and then inside of those parallel lines. Alternate interior angles are always congruent if your lines are parallel. So that's why we can do that. So that's how I will do these problems. If I ever see angle of depression, I will just throw it down where the angle of elevation would have been. Okay, so first word problem. When an airplane begins its descent to the airport, it is 3,900 feet from the ground. Its angle of descent is 6 degrees. What is the ground distance to the airport? Okay, so first thing I would do here is I would kind of make just a plane, and you can just make it a dot. And then we have like the airport here that's on the ground. All right, and then we have this plane that's coming in like this. And then they want to kind of know, I think, or they want the ground distance. So I'm going to finish making this triangle. They want this ground distance here. How far is this plane from the airport if we're looking at the ground? So kind of how many miles away. Other information they give us. They say that it is 3,900 feet from the ground. So this distance here is 3,900 feet. And then here's the tricky part. They give us the angle of descent. That's the same as the angle of depression. Depression, descent, same thing. They both start with a D. So they're giving us actually this angle out here is 6 degrees. Like I said, I would take that angle and put it down here. Now it's inside your triangle, and you can kind of ignore that 6 degrees on the outside. Okay, so looking at what we have and what we know, we have this angle here. We have, from that angle, we have the opposite side. We are looking for the adjacent side. That's a tangent. So tangent of 6 degrees is equal to 3,900 over x. I'm going to take the shortcut, and I'm going to say x is equal to 3,900 over tangent of 6 degrees. Grab a calculator. And we get 37,106. 37,106. And that's in feet. Just double checking that I wrote that down right. All right, which makes sense. You have a teeny tiny angle, so you're going to end up with a very big number on the bottom there. Then part B, how far must the plane fly to reach the airport? So this is actually the path of our plane. So now we are looking for that distance. A couple ways you could do it. You could use the Pythagorean theorem, or you could just use trig again. I tend to just use trig because I actually think it's easier. So I'm going to call that the hypotenuse. I'm going to ignore this bottom side here and just use the 3900 that we were given originally. So that's going to be a sine, opposite hypotenuse. So sine of 6 is equal to 3900 over y. And then y is going to be equal to 3900 over sine of 6. And we're going to get 37,310. And we'll just go to the nearest whole number there. And then just double check that that's the biggest number. And it's close. Our longest leg was 37,106. Our hypotenuse is 37,310. So not a whole lot longer, but it is longer. So we should be good to go there. All right, next one. A chairlift has to go up a mountain that is 1,200 feet high. The horizontal distance the chairlift travels is 3,126 feet. What is the angle of elevation the chairlift travels? So when you're given a lot of information like this, and it really doesn't have to be perfect, you know that these are all going to be right triangles. So sometimes before I even really start reading, I'll just create myself a right triangle and fill stuff in. And if it doesn't look perfect, if the picture doesn't really match the situation perfectly, it's not really that big of a deal. So right now we have this chairlift going up a mountain that's 1,200 feet high. So if I see the word high, I'm probably going to use a vertical length there. It says the horizontal distance is 3,126 feet. And then it looks like they're looking for the angle of elevation. Well, that's easy. Angle of elevation is always kind of from the ground up there. So we can just call that, I don't know, A, angle A. And then to do this one, looks like we have the adjacent side and the opposite side. So we're going to use tangent. Set that up. And then to get rid of a tangent, we're going to take the inverse of both sides. Punch that in a calculator. 1,231.26. And you get about 21 degrees. All right, I'm going to leave it at that. On the worksheet, there is a little bit of all of this. Some finding single sides, solving triangles, and some word problems. So good luck.